is Kulkarni here, and we are going to talk about heating and cooling curves today. So what do you mean by heating and cooling curve? Let's look at one of the heating and cooling curve. This is what it looks like. And we have on our y-axis there, we have temperature, and on x-axis it can be time, or we can also say we have progress of the reaction. Either one is fine. And then it looks like a step ladder if you look carefully. Along the first slope over here, you can see particles are very compactly arranged. That is a solid. Then the next slope here, the particles are little loosely arranged, and that is a liquid. And over here, the third slope, you can see particles are loose, they are just flying all over, that is a gas. Okay, so how we are going to explain this? As we get the solid heating, what happens? Temperature keeps on changing, okay, as we heat it. So up to a certain point it gets heated, and look what happens over here. At a certain point when it comes, the temperature remains constant and we go from solid to liquid. What is it called? Solid to liquid will be called as a phase change, which is melting. And of course, if it goes from liquid to solid, you know that is going to be, what is it going to be? Liquid to solid will be freezing. The way we make ice cream, so it will be freezing there. And then this slope which we have here is representing solid. Let's move on over here. Liquid gets heated and we get slowly temperature rising till again we come back over to this point, and then the temperature remains again constant. And what do we go? From liquid we go to gas. If liquid goes to gas, we call that as vaporization. You got it right. And then if it's reversed from gas to liquid, then it will be condensation. Okay. So this is going to be liquid and this is going to be gas phase. Now let me explain to you one more time. All these slopes which we are talking about, all these sloping lines, they represent some phases: solid, liquid, or it is gas. And then we have these lines which are parallel to our x-axis. That represents a phase change. The phase change here is solid to liquid or liquid to solid. And over here, it's liquid to gas or gas to liquid. It is that simple. And keep in mind, the temperature remains constant when we have a phase change taking place. Let's look at these two questions. During a phase change, what is happening to the temperature of the substance? You are still continuing to heat the substance. But whenever there is a phase change, remember those are the flats which we see in the graph. There is no temperature change. So we have temperature remaining constant. It remains constant. So you can add there, remains same or remains constant. The next one here is we are expected to draw a heating curve for bromine. And then we need to label both the axes. What is given here? TB, the boiling point, is given to you 59 degree, and TM, melting point, is -7 degree. Now let me tell you what I do. I always draw y and x axis here, and your one temperature is negative, so I'm making sure I have some room here to show that -7 degree temperature. Let's say maybe that's -7, and I just take roughly, this is 59 degrees. That's going to be my temperature on y-axis. So that is the temperature of substance, and this is going to be time or the progress of the reaction. So remember again, whenever it's melting point or boiling point, what we end up getting are those flats. That means it remains same. So I know pretty much I will have a flat over here. This is going to be a flat line. Also, at this temperature, I will be having a second flat over there. And then it is extremely simple. We are simply going to have these two connected, that connected, and there you go. We ended up getting a phase diagram for liquid bromine. Okay, let's move on to our last question about phase diagram. And in this phase diagram, you probably first need to label what it is, but what we're going to do is answer those questions. So that's a phase diagram. A to B, you know it's solid. C to D, you know it's liquid, and this is going to be gas. And what is this? You know B to C and D to E are phase changes. So let's look at the first question. Between which points is there a phase change taking place? Wow, that was simple. Between B and C and between D and E, there is a phase change because it's simple. You have exactly same temperature between those 2 points. So it is B and B to C, or of course C to B, and then we also have D to E, or vice versa. It will be the temperature remaining same. That means we have a phase change. The next question is, what is taking place as you move from point E to D? If you are going this way, what are we doing? We are moving from gas to liquid. If you go from gas to liquid, what is it called? It is called condensation. That's the way we get dewdrops in the morning. What phase exists between point A and B? Along A and B, what do we have? That is simply solid. And it's not asked there, but you can say, what do we have a phase along the C and D? If it's C and D, it's going to be liquid. And then last question which we have is, what phase exists between point B and C? Well, around point B and C, what do we have? It is actually going from solid to liquid. So solid is getting converted to liquid. So at a particular point, we will have an equilibrium between solid and liquid. So we will actually get to see both those phases, and gradually it will change from solid to liquid. And I hope you like the video, and then I will see you in next video. Bye.